Alright, this is 3.5, slopes of lines. We talked about this a little bit yesterday, so I'm going to go kind of quick through the first part as a review and then really dive in deep to the second part so that you're successful on your homework. So I'm going to skip these warm-ups. Again, you can find this on Google Classroom or on my website. We talked about slope. It describes the steepness of a line. So slope can be defined as rise over run. And we came up with a slope formula that we should have in our notes and on our foldable. So we found the slope of a few different lines yesterday. So let's look at just line AB here. Line AB. This was on our handout. This is a horizontal line, right? It's flat, okay? So if you're looking on your handout, we know the slope of a horizontal line is always going to be 0, but you can test the points. You can do the formula and you get 0 divided by 5 is 0. AC here, here's AC. Just looking at it, if we know that it's decreasing, right, from left to right, it's going down, then we know its slope's got to be negative. So we could go in and we could calculate the slope, but we need to make sure that our answer is negative, and it is. AD here, this is rising, it's increasing from left to right, so we know it's going to have a positive slope. Oops, wrong one. AD, not DC. AD is up and down, and a vertical line is an undefined slope. Okay, so we can automatically jump to the conclusion that the slope will be undefined here. And then CD is the positive line because it's increasing from left to right. So we need to make sure that our answer is positive. And then we practice using the slope formula to determine the slope through 2 different points. So we labeled these x1, y1, x2, and y2. We plugged them into the formula and we reduced our fraction and got 2. Again, positive slope is increasing, negative slope will be decreasing, 0 slope is a horizontal line, and undefined slope is a vertical line. Okay, 2 important theorems. The first one is the parallel lines theorem. It's saying that 2 non-vertical lines, so they can't be straight up and down, are parallel if and only if they have the same slope. So what it's saying is if you find 2 lines that have the same slope, then you can call them parallel. Or if you have 2 lines that are marked parallel, you can call them the same slope. They have the same rise or the same run. Okay, that makes sense. They're the same steepness, so they ought to be parallel. Okay, the next one, the perpendicular lines theorem, says 2 lines are perpendicular if and only if the product of their slopes is -1. So what that's saying is if I get a slope here of, let's just say 2 to make it easy, and I get a slope here of -1/2. Well, what's the product of these? So if I multiply -1/2 times 2, I will get an answer of -1. So I know that these slopes, 2 and -1/2, are perpendicular because when I multiply the slopes, I get -1. Okay, also horizontal and vertical lines are going to be perpendicular. So let's think more about this perpendicular line when the product is -1. Okay, so if a line has a slope of a over b, whatever that is, maybe it's 7 over 8, then the slope of a perpendicular line would have to be flip it, so 8 over 7, and then take the opposite sign, so this one would be negative. So these 2 lines are going to be perpendicular. Okay. These ratios are called opposite reciprocals. All right. Just like with 2, the opposite of 2, think of 2 as a fraction. The opposite reciprocal would be flipped, 1 over 2, and then the opposite sign. What's the opposite reciprocal of 5, 6? We'll flip it, and the opposite sign would be positive. So these are examples of opposite reciprocals. Opposite reciprocal slopes mean perpendicular lines. Okay, so some type of problems that you're going to get are determining whether lines are parallel, perpendicular, or neither. So we have three options to choose from. First, what we want to do is graph each pair of lines and use the slopes that we calculate to see what we get. So if I plot these points at 0, 2 is u, -1, -1 is v, 3, 1 is x, and -3, 3 would be y. Okay, so let's find the slope of uv because it wants to know between lines uv here and lines xy here, are they parallel, perpendicular, or neither? So let's start with uv. Let's find the slope of uv. So I'm using the points u and v. I can label them x1, y1, x2, and y2. So I want to subtract my y's, so -1 minus 2, and then subtract my x's, -1 minus 0. So I get -3 over -1. A negative divided by a negative is a positive. 3 over 1 is just 3. Now let's find the slope of xy. So label it x1, y1, x2, and y2, and go ahead and subtract. 3 minus 1 over -3 minus 3. 3 minus 1, -3 minus 3. I get 2 over -6, which would reduce to -1/3. Now the product of these slopes is -1, so that must mean these lines are perpendicular, right? When I take 3 times -1/3, I get -1. So the lines, therefore, are perpendicular. Don't just trust the picture. Remember, don't eyeball it. Actually calculate for me the slopes. Okay, new points here. I have GH and IJ as my lines, so let's plot G at -3, -2. H is at 1, 2. Then I have I at -2, 4. And J at 2, -4. So it looks like they could be perpendicular, but I never know, so let's check them out. Let's find GH's slope. So plug in y2 minus y1, x2 minus x1. Minus a negative is plus a positive, so I'd get 4 there. Again, minus a negative would be plus a positive, so I'd get 4 there, which would reduce to 1. And then let's find the slope of ij. Go ahead and label them. So I'd get -4 minus 4 over 2 minus -2. -4 take away 4, we're back at -8. And minus a negative would be plus a positive, so that would reduce to -2. Now when I multiply these, -2 times 1, I'm getting -2. I'm not getting -1. So the product is not -1. So that means the lines are neither. Why aren't they parallel? Because they're not the same exact slope. Okay, and obviously by the picture they're not parallel. So this is neither parallel nor are they perpendicular. Okay, I'm going to let you try this one. Go ahead and pause the video and graph and see what you get. Okay, hopefully you found out that the slope of CD was 2 and the slope of EF was 2, so since they have the same slope, the lines are going to be parallel. All right, best of luck on your assignment. If you need help, ask Mr. Mason.